Alright, welcome back to our series of chemical reactions PowerPoints from Mr. Voigt's Physical Science 9 class. This is number 4 in our series of chemical reactions presentations. Today's topic is the types of reactions. It's helpful for us when predicting the results of a chemical reaction to understand what type of reaction it's going to be. As we've talked about throughout the class, we want to recognize patterns in nature, and patterns allow us to predict things. So if I understand the pattern of a type of reaction, then I can easily predict what the type of products is going to be. Now, we typically think of 5 different types of reactions. The first is synthesis. Synthesis is described as taking 2 things and putting them together to make one. Decomposition, which is the opposite of synthesis, is when you take one thing and break it down into 2 or more things. Single replacement reaction is when one lone element replaces another element of the same kind in a compound. And double replacement reaction typically occurs when 2 ionic compounds trade partners. And our last is combustion. Now, combustion is something that's not covered in your book, and combustion is when a hydrocarbon, which is made up of carbons and hydrogens and oxygens, reacts with oxygen to produce CO2 and H2O. Now, in a combustion reaction, all of this stuff, from the O2 to the arrow, CO2 plus H2O, always stays the same. The only thing that will change then are the numbers underneath these C's and the H's and the O's. In fact, sometimes the O might not even be there. And our last type of reaction is acid-base reaction, but as it states here on the slide, this is similar to double replacement reaction. And we know that an acid is something that starts with an H, so HB plus AOH reacts to produce AB plus H2O. Again, one of our products for an acid-base reaction is going to be water. A has to be a metal, and B has to be a nonmetal. Now, we can take a closer look at the reaction models from our book, and here we can see synthesis reaction. The book kind of uses the analogy of a school dance. You can see here that 2 people show up to the school dance separately, and throughout the dance they decide to dance together. So we have 2 people becoming one thing. We have a boy and a girl forming together to be a couple. So the example here is 2Na plus Cl2 react to produce 2NaCl. In a decomposition reaction, this is again the opposite of synthesis. This is a couple showing up at the dance and then leaving separately. So here we have the boy and the girl dancing, and then in the process of a chemical change, the boy separates from the girl and they go on their separate ways. In a single replacement reaction, this is kind of like a dollar dance at a wedding, or somebody cutting in on you when you're dancing with a boy or a girl. So you can see the boy here is going to replace the boy in the purple shirt in this couple. So now in the product side we have the girl dancing with the boy in the yellow, and the boy in the purple is all by himself. It's important to remember that boys in this analogy have to replace other boys, and girls would replace other girls. To give you a better example, the metal would have to replace the metal, or in actually this case it would be replacing the positive ions. So positive ions have to replace other positive ions, negative ions have to replace other negative ions. Our double replacement reaction, this is what you might find in a group date situation. We have everybody as friends. They're kind of, these 2 are dancing together, the boy in the yellow and the girl in the green, and then the boy in the purple and the girl in the blue are dancing together, but some way through the middle of the dance they switch partners. Now the boy in the yellow is dancing with the girl in the blue, and the boy in the purple is dancing with the girl in the green. It's important for us to recognize what types of reactions we're dealing with, because like I said before, these patterns will help us predict the result of chemical reactions.